Hi, so in this video, I'm going to talk about why is 1 not a prime number. I know you may have the urge to sort of give me the definition of a prime number, and let me pull that up for you. So the definition of a prime number is a whole number greater than 1 that cannot be exactly divided by any whole number other than itself and 1. Right, so you give me this definition and you look at me thinking that I'll get to know why 1 is not a prime number, because by definition, it is not greater than 1, right? The definition of a prime number is a whole number greater than 1. And there is another definition that goes on, right? That a prime number is a number that has exactly two distinct factors, right? So then again, you look at me and want me to figure it out by myself that, yeah, that's why 1 is not a prime number, because it has only one distinct factor, which is 1. It does not have two distinct factors. But unfortunately, you don't see that sign of aha moment within me that, oh, I have understood why is 1 not a prime number. Rather, the curiosity within me sort of continues to exist. And then I ask you that question, but why is this even the definition of a prime number? Why are we saying that a prime number has to be a whole number greater than 1? Why not allow it to be any whole number? Or you are saying, okay, a prime number has to have two distinct factors. My question is, why exactly two distinct factors? If it has one, then what is the problem, right? You are okay with 1 into 11. So let's say you'll say that 11 is a prime number, right? Why is 11 a prime number? Because it has two distinct factors, 1 and 11. Then why don't you allow 1 also to be a prime number, right? Why restrict it to that only exactly two distinct factors? So essentially, I'm asking you the question, why is the definition of prime number so? And then you're like, as a definition, so what kind of question is that? Definition is so because the definition is so. Right? But this is the question I want to talk about essentially in this video, and eventually by the end, we'll have figured out uh, the long answer to this short question, that why is 1 not a prime number. So before we get into why is the definition of prime number so, let's try to understand why prime numbers are called prime numbers. Why have they chosen this name, prime number, for this? Why? What is so prime about them? So let's try to first understand uh, the origin of this prime. So where does the word prime come from? It comes from the Latin word primus, which means first. Okay. So if you look at in the mathematical context, a prime number is a whole number. So whatever, a prime number is a kind of a first number. Why is it first? Because if you look at any prime number, it cannot be derived from some other numbers. Okay, so let me give you an example. So if you have 11, you cannot arrive at 11 by multiplying some two smaller numbers, right? So it is a first number, or the prime number, we say. But if you look at 12, I can arrive at 12 by multiplying a few smaller numbers together, and then I arrive at 12. So it is not really a first number, right? It is just a secondary number that I can arrive at by using primary numbers, right? So the prime numbers are the primary numbers or the first numbers that you cannot arrive at by multiplying some smaller numbers. Okay, so whether you look at 11, 13, 17 and all that, these are prime numbers because they're the first numbers. So essentially that's why they are called prime numbers. But we use the word prime in a lot of other contexts also, right? Prime minister. Why is the prime minister called prime? Because he's the first among the equals, right? Similarly, prime time, prime example. Why? Because they are the first in some way. They're the best in some way. That's why they are called prime. That's the meaning of the word prime. Okay. So, so I've asked this question, why are prime numbers called so? Why are prime numbers called prime? Because they are the first number. They're the prime numbers. They're the fundamental building blocks in math. Okay. They cannot be arrived at by some other numbers. Okay. So that is why they are called prime. Now the question is, why is one not prime? Right? One also cannot be arrived at by using some smaller numbers. Right? So why is one not prime? Rather, you might be uh, interested. It might be interesting to know this, that the definition of prime numbers included one at some time. Okay, if you look at this, by the early 20th century, they agreed, mathematicians agreed that one should not be considered a prime number. So before that, this time, so even till late 19th century, one was considered a prime number. Rather, if you go on here, some mathematicians, including this, still treated one as prime into 1930s and 40s. Rather, lists of prime, including one, were published as late as 1956. Okay, so it is a recent phenomenon, depending upon what we term recent. But essentially, one was considered prime for a long period of time until it was not. And this definition, or one was excluded from being considered prime in the early 20th century. But why? But why was one excluded? Right? And if you look at the exclusion uh, of one, do you remember something happening to some other thing in some other domain also? Something was considered something. It is very abstract way of asking you. But if you look at the example of Pluto, you know Pluto. Pluto was considered ninth planet in the solar system, right? So solar system used to have 9 planets. Now it has 8 planets. So Pluto was demoted from being considered a planet to not being considered a planet. Now it's considered something called a dwarf planet. So Pluto was considered a planet till 2006. And in 2006, the definition of planet was changed to exclude Pluto from being considered a planet. And this is a very interesting statement to make. The definition was changed to exclude Pluto. A lot of people think that Pluto is not a planet because it doesn't satisfy the definition of a planet. What I am saying is the definition was changed to exclude Pluto. So first they decided, well, we don't want to have Pluto. We don't want to have Pluto as a planet. Okay. But the definition allows it. No. Oh, so let's change the definition. No. This is what is happening. So you first decide to exclude Pluto, then you say, well, there's a conflict. We don't want to call Pluto a planet, but the definition allows it. Okay, so let's change the definition. This is what happened in the case of Pluto. So did the definition of a planet change in 2006? Yes, the definition of a planet was officially changed in 2006. Why was it changed? So I've done this research. So I'm asking this direct question: why did the discovery of Eris? So essentially, in 2006, what happened was astronomers discovered uh, a planet-like thing very close to Pluto. Okay, and it was almost the same size, or initially it was considered even bigger than Pluto, very close to Pluto in the same orbit. So then they were like, oh, if we allow Pluto to be a planet, we'll have to allow this also these also to be planets, not just one, possibly many of them, right? So you look at this. If Eris was considered a planet and it appeared to be larger than Pluto, it would lead to a large and potentially endless list of planets in the solar system. So in 2006, given the discovery, they were in a situation, well, if we call Pluto a planet, then we'll have to call a lot of these also planets. So suddenly we'll have not 9 planets, but endless list of planets. That's horrible. So then what do we do? Simple. Yeah. Don't even call Pluto a planet. So then we'll be done with all this. So let's just limit ourselves to 8 planets. Then we'll sort of save ourselves from this complexity, this nonsense of having a lot of planets. Just don't feel like having a lot of planets. So it may not be exactly about feeling, it may be about, again, simplicity, elegance, I don't know, whatever factors they consider. But it could essentially, it is, I think, around aesthetics, not just pure logic. So in 2006, this happened that, well, if we call Pluto a planet, then a lot of other things will also need to be called planets. So let's exclude Pluto. But how do we exclude Plutos? Pluto is a planet by definition. So let's change the definition of a planet. Okay, so in 2006, the definition of a planet was changed. Okay, and that's the same thing that happened with prime numbers. Okay, so the definition of prime numbers was changed to exclude one. We think that one is not a prime number because it does not satisfy the definition. Well, no, we are getting the order wrong. The definition itself is designed to exclude one. You understand? We you understand the order difference. Okay, so now we may ask, but what is the problem with calling one a prime number? Why was the definition changed to exclude one? What enmity do they have against one? Why can't they just call one a prime number? So let me, for to answer that question, we'll have to go to the fundamental theorem of arithmetic. What does this theorem say? This theorem says that every positive integer greater than 1 can be written as a unique product of prime numbers. Okay, what that means is, let me go back to my board and explain you. Every number can be expressed as a unique combination of prime numbers, right? Let me see that. Yeah, unique product of prime numbers. So for example, if you look at 12, I'm again looking at 12, it can be written as 2 into 2 into 3. This product of prime numbers. Now, there is no other way to write 12. You can't just write 12 as, okay, 5 into some other prime number. That's not possible. It is always a unique product. Okay, for example, you can look at any number actually, 54. If you break it down, it will be 2 into 27, which is 2 into 3 raised to power 3. Now, this is the only way 54 can be broken down into prime numbers. Okay, this is unique. So you may think, well, why not? It could be that let's say there is some other prime number, let's say 13, and I can multiply 13 with something to arrive at 54. Well, this may never happen. This doesn't happen. Okay, so that's the fundamental theorem of arithmetic, that every number greater than 1 has a unique product of prime numbers. Okay, so this is the fundamental theorem of arithmetic. Now, of course, as I asked why are prime numbers called so, I may also ask why is this theorem called fundamental? So I have asked that question also because perhaps I don't know the whole complexity of it, but essentially this theorem is possibly called fundamental theorem because it is really fundamental. It is really the base of a lot of things and arithmetic. So perhaps that is the reason. But Going back, so then it's okay. That's understandable that this is what the fundamental theorem of arithmetic say. But what does this have to do with exclusion of one from prime numbers? The reason is that if I call one a prime number, then what happens? Then I can write 12 as 2 into 2 into 3, or I can write 12 as 1, which was not there. Now suddenly 1 is there. So now this is not a unique combination anymore. I can write 12 as this also, and 12 as this also, and 12 as, by the way, 1 into 1 into 2 into 2. Right? I can keep adding ones. So suddenly the prime factorization of 12 is not unique. Okay. So if I call one a prime number, the fundamental theorem of arithmetic does not hold. Okay. So to make the fundamental theorem of arithmetic hold, the mathematicians decided to exclude one. Okay, so this is the reason it was decided that we will not call one a prime number. Then the definition of a prime number was changed to exclude one. This is the order of things. Okay. So, but then when I was reading all this, uh, and this is essentially one of the questions I asked, what is the conflict between calling one a prime number and the fundamental theorem of arithmetic? So essentially the answer was calling one a prime number would violate the fundamental theorem of arithmetic because it would allow for multiple different prime factorizations of the same number. As I just explained, for 12, it could be 2 into 2 into 3, or it could be 1 into 2 into 2 into 3, and you can add a lot of ones, right? So suddenly you will not have a unique prime factorization of a number. You'll have multiple different prime factorizations. So I understood all this, but I also know that mathematicians uh, or science in general also, if something is not really fitting in exactly as they want it to fit in, they add constraints to things, right? For example, even the definition of a prime number was changed to say, okay, it's a number greater than 1. Initially, it was very elegant. Any number that can be divided by 1 in itself was called prime. But if that definition was not working, they changed it to say, oh, any number greater than 1, right? So then I thought of this, and I had this question that instead of excluding 1 from prime numbers, right, the mathematician decided to exclude 1 from prime numbers. Instead of doing this, why didn't mathematicians add a constraint regarding 1 to the fundamental theorem of arithmetic? Essentially, what I mean is they could have, instead of twisting the definition of a prime number, that okay, it's a number greater than 1, they could have changed the fundamental theorem of arithmetic to say that, well, every number has a unique prime factorization of primes greater than 1, right? So it is a so they could have added that greater than 1 constraint in the theorem also. Instead of excluding 1 from prime numbers, they could have changed the definition of the theorem itself and added greater than 1 there, right? Why didn't they do that? Why didn't they do it? Essentially, the answer is, and you can, of course, go through all this. Essentially the answer was that excluding 1 from prime numbers is simpler and maintains the uniqueness, which is essentially makes the theorem hold. But it is simple. What does it mean? It's simple. They both seem to be the same, right? You change the definition here, you change the definition there. Why is one simpler over the other? Actually, what I later figured out, and actually this is given here straight away, but what I also realized as I was talking to various AI tools, ChatGPT, Claude, and all that, essentially one is not considered prime because mathematicians figured out that it is not really, they don't really gain by calling it a prime. But calling it a, so there is no gain in calling it a prime, but if you call it a prime, then you'll have to change not just this theorem, but also a number of other theorems. Okay. And it says it actively messes up some theorems. So essentially, you'll not have to put a constraint just to this one theorem, but perhaps a lot of other theorems also. So instead of adding constraints everywhere, they said, well, what's the point? This one is not really serving us as a prime. We are not really gaining anything from it. So let's stop calling it a prime. So let's just go and change the definition of a prime number to exclude one. Okay, so this is what happened. And that's why one is not a prime number. So that's a long answer to this short question. I hope this helps. If you have any questions regarding this, or if you have other questions regarding basic math, because I've not done any bachelor's in math, so I just know the basic math. If you have any questions around whys of basic math, then you can feel free to ask in the comments. Thank you.